If life had taken 10% longer to evolve on Earth, it wouldn't exist at all for nearly half a century. NASA's Voyager spacecraft has journeyed through space, beaming back secrets from the cosmos. Recently, a startling message reached Earth, sparking curiosity and concern. NASA has revealed that the probe encountered something inexplicable out there in the vastness of space. What exactly did Voyager stumble upon, and what would it mean for us here on Earth? Join us as we uncover the secrets behind NASA's warning about Voyager 1's deep space encounter. NASA's Voyager spacecraft are incredible marvels of human ingenuity. These machines, born in the 1970s, have defied the odds and ventured beyond our solar system, exploring uncharted territories and beaming back revolutionary discoveries to Earthbound scientists. What's truly mind-boggling is that despite their age, these spacecraft have a memory capacity that's 3 million times smaller than your average smartphone and transmit data at a speed that's a whopping 38,000 times slower than the lightning-fast 5G internet we're accustomed to today. Despite these limitations, or perhaps because of them, the Voyagers have become legends in the realm of space exploration, achieving feats that were once thought impossible. And just when we thought we knew everything about them, they surprise us yet again. Recently, the Voyagers made a discovery that has sparked a heated debate among scientists. Some are cautiously optimistic, hoping it's a glitch in the system rather than a genuine finding, while others are excited by the prospect of a groundbreaking revelation. What adds to the intrigue is the way this discovery was delivered. It's almost as if the Voyagers had to overcome a cosmic obstacle, battling against an unknown force to ensure that their message reached us here on Earth. Let's start by exploring the remarkable backstory of these extraordinary probes that have tirelessly gazed into the vastness of space on behalf of our planet. The genesis of these incredible spacecraft can be traced back to a celestial phenomenon that occurs only once every 176 years. During this rare event, the 4 largest planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, act as celestial guides, creating a gravitational slingshot effect. This cosmic dance essentially propels a spacecraft forward, harnessing the immense gravitational forces of these giant planets like an invisible celestial rope. However, this alignment comes with a significant caveat. It happens just once in nearly 2 centuries. Despite this limitation, the alignment presented an unparalleled opportunity for interplanetary exploration. NASA, recognizing the magnitude of this celestial event, seized the moment. In the mid-1970s, they meticulously crafted 2 identical spacecraft to embark on this epic interstellar journey. Capitalizing on this golden window of opportunity for interplanetary exploration, the Voyager spacecraft embarked on their epic journey from Cape Canaveral, Florida, on September 5, 1977. Voyager 1 soared into space, propelled by the Titan IIIe Centaur rocket. Just weeks later, on August 20, 1977, Voyager 2 followed suit, commencing a parallel odyssey into the depths of the cosmos. Initially tasked with exploring the gas giants Jupiter and Saturn, along with their captivating moons, these intrepid probes exceeded all expectations. Their mission expanded to encompass the farthest reaches of our solar system, venturing into uncharted territories beyond the realms of the gas giants. Along their historic journey, Voyager 1 and Voyager 2 achieved remarkable milestones. They have outlasted any other spacecraft in history and journeyed farther from Earth than any other human-made objects. Most notably, they breached the boundaries of interstellar space, becoming the first creations of humanity to transcend the sun's influence and venture into the vast expanse of our galaxy. Their expedition into interstellar space, spanning over 12 billion miles from Earth, has yielded a wealth of invaluable data, leaving scientists in awe of their discoveries. One recent revelation, which we'll explore in detail shortly, involves a warning signal detected by the space pioneers and confirmed by NASA scientists. The Voyager's exceptional capabilities are owed in part to their innovative use of self-powered radioisotope thermoelectric generators, RTGs, which have sustained their operations across the vast distances of space. These nuclear batteries, also known as radioisotope power systems, RPS, harness the Seebeck effect to transform the heat from decaying plutonium into a steady stream of electricity. What's truly remarkable is that these RTGs operate seamlessly without any moving components, greatly reducing the risk of mechanical wear and tear. This characteristic makes them exceptionally reliable for enduring the harsh and distant environments encountered during deep space missions. One of the standout advantages of these generators is their independence from solar energy. Unlike solar-powered systems that rely on sunlight, RTGs can function efficiently in regions where sunlight is scarce or non-existent, making them ideal for missions venturing into the depths of space. However, there's a caveat to this impressive technology. Over time, the decay of plutonium within the RTGs leads to a gradual decrease in power output. Despite this natural degradation, the overall mission integrity remains intact thanks to the proactive measures implemented by NASA engineers to counteract the diminishing power supply. Engineers have strategically disabled heaters and non-essential systems that have no bearing on the spacecraft's essential flight operations. This proactive approach ensures that the Voyager spacecraft continue their mission effectively, navigating the cosmos and delivering invaluable scientific insights back to Earth. The Voyager spacecraft was ingeniously equipped with a unique 8-track tape system for storing and playing back data, a technological marvel that still astounds today. Now, here's a breakdown of how this system works. First, the array of scientific instruments aboard the Voyager probes captures a diverse range of data, including images, audio recordings, and various measurements. This raw data is then converted into a digital format for processing. Next, the digital data undergoes serialization and is meticulously stored on the specialized 8-track tapes. These tapes feature 8 parallel tracks, ensuring efficient and organized storage of vast amounts of information. When it's time to relay this data back to Earth, the onboard computer autonomously reads the relevant data from the designated tracks on the tapes. This read data is then transmitted through the spacecraft's communication system, primarily utilizing its high-gain antenna to beam the valuable information back to our planet. On Earth, sophisticated receiving stations intercept and decode the transmitted data, preparing it for in-depth scientific analysis and interpretation. What makes these tapes truly extraordinary is their robust construction, specifically tailored to withstand the harsh conditions of space. They typically consist of a metallic base layer, often made from materials like stainless steel, renowned for its resilience against radiation, extreme temperatures, and the vacuum of space. Each track on these tapes is coated with a magnetic material specially designed to preserve the integrity of the stored digital data, ensuring minimal degradation over time. Additionally, the tapes are encased in protective enclosures, shielding them from potential hazards such as micrometeoroid impacts, further enhancing their durability and reliability. Despite their vintage design, these 8-track tapes continue to operate seamlessly, dutifully transmitting crucial data back to Earth each day. The accomplishments of the Voyager spacecraft have been truly amazing. When they first started exploring Jupiter and Saturn's moons more than 40 years ago, they amazed scientists and changed what we thought about these faraway places. Instead of being quiet and covered in craters like our moon, these moons turned out to be full of action, with lots of things happening on their surfaces. Voyager 2 especially hit some big milestones during its trip. In 1986, it became the first spacecraft to get close to Uranus. Just 3 years later, it flew past Neptune, a record that still hasn't been beaten. As these spacecrafts keep traveling, NASA has taken steps to keep them going. They've turned off some parts that aren't needed and heaters to save power. This means the Voyagers can keep working until at least 2030. For the scientists and engineers who have worked on this project from the beginning, it's a mix of happiness and sadness as they see it reach its end. They put in a lot of effort and went way beyond what they thought they could do. The data the Voyagers have sent back has been super valuable, leading to tons of new discoveries and getting people excited about space for years to come. You see, Voyager 1 and Voyager 2 weren't your average spacecraft. They were built with extreme precision, rotating at a speed more than 15 times slower than the hour hand of a clock. This slow rotation ensured that the images and data they collected during their space journey were crystal clear, without any blurriness. Their remarkable ability to capture images amazed both scientists and the public. Long before they reached the outer planets, months before getting close to Jupiter, they started beaming back images of the gas giant, showing its swirling clouds and the famous Great Red Spot. These early glimpses were a hit at NASA's Jet Propulsion Laboratory. But what really stole the show was their discovery of active volcanoes on Jupiter's moon, Io. This moon, a bit bigger than our own moon, turned out to be the most volcanic place in our solar system. The spacecraft's instruments picked up strange signals from Io, which were confirmed by the stunning images they snapped. These images revealed towering volcanic eruptions and a surface scattered with volcanic material. One of Io's volcanoes, Pele, has erupted so high that it could cover an area almost as big as France. In total, the Voyager duo captured more than 33,000 images of Jupiter and its moons, showcasing the planet's beauty and the fascinating variety of landscapes across Jupiter's moons. Prior to the recent alerts, the twin Voyager spacecraft have been uncovering amazing things ever since they were launched. One of the big surprises was finding out that Jupiter has rings around it. These rings might be faint, but they're a big deal and make Jupiter even more fascinating. Voyager 2 also showed us that Europa, one of Jupiter's moons, has a really thick, icy shell, more than 60 miles thick. This discovery shook up what we thought we knew about these faraway celestial objects and got scientists excited about whether icy moons like Europa could be places where life could exist. When the Voyagers left Jupiter, they got a boost from its gravity, like a goodbye push that sent them flying towards Saturn. This boost was crucial because it helped them break free from the sun's pull and continue their journey into space. After saying goodbye to Jupiter, Voyager 1 and Voyager 2 went their separate ways. Voyager 1 swung by Saturn's moon Titan, covered in a mysterious orange haze, sparking scientists' curiosity about its complex chemistry. Then it headed upwards, leaving the planets behind and venturing into the unknown beyond our solar system. On the other hand, Voyager 2 went on a grand tour of the outer planets. It made history in 1986 by buzzing past Uranus and discovering 10 new moons there, bumping up Uranus's moon count by quite a bit. 3 years later, Voyager 2 reached Neptune, showing us the incredible features of this icy giant from afar. During its visit to Neptune, Voyager 2 clocked wind speeds of up to 1,000 km/h, the fastest ever on a planet in our solar system. The spacecraft got as close as 2,980 miles to Neptune's blue methane-filled air, giving us new insights into this faraway place. Neptune's biggest moon, Triton, turned out to be one of the coldest spots around, with temperatures plunging to 391 degrees Fahrenheit on its surface. Triton also has some cool stuff, like ice volcanoes shooting out nitrogen gas and icy bits reaching 5 meters high in its thin air. These discoveries helped us see how diverse and complex our solar system's objects are, even out in the farthest reaches. Someone crucial in pushing these missions further was the famous astronomer Carl Sagan. He was part of the Voyager team and pushed hard to snap one last set of pictures before both spacecraft cameras shut down. His determination paid off, giving humanity a final look at our home planet from way out in space. Back in 1990, Voyager 1 turned its camera towards our solar system's inner parts and snapped 60 pictures. One of these pictures, famously called the pale blue dot, has become a symbol we can't forget, reminding us of where we stand in the vastness of space. Taken from an incredible distance of 3.8 billion miles, this image is the farthest one ever taken of our planet. In this picture, Earth looks like a tiny pale blue dot, almost lost in the vastness of space. The Voyager spacecraft has given us new insights into how empty interstellar space really is. NASA's observations show that cosmic rays are 3 times stronger outside our solar system's protective shield, called the heliopause, compared to inside it. But there's more to this fascinating story. Scientists have combined Voyager's discoveries with data from later missions, uncovering a strange humming sound recorded by Voyager 1. This mysterious resonance seems connected to unusual waves found in tiny amounts of gas in the harsh conditions of interstellar space. However, not everyone agrees on where these strange sounds come from. Some passionate science fans believe they could be caused by beings from other worlds. For more than 4 decades, the Voyager missions have been on a mission to uncover the secrets of our solar system. What they've revealed has been astonishing and even a bit weird. Scientists have discovered that the heliopause, the boundary that separates our solar system from interstellar space, isn't a fixed line. It's a constantly shifting barrier that changes its shape over time. This unusual behavior has left experts puzzled and a bit worried about what it could mean for the future. In addition to this, the Voyager spacecraft has gathered incredibly valuable data about the Sun and how it impacts our solar system. This information has given us a deeper understanding of how this massive celestial body influences everything around it. Perhaps the most surprising aspect is how the Voyagers have continued to operate in temperatures much colder than they were designed for, challenging our usual expectations of technology's capabilities. As scientists combine Voyager's data with findings from other missions, they're starting to create models that predict how the heliopause might change in the coming years. However, the unpredictable nature of these forces means we can't predict with certainty what lies beyond the edge of our solar system. Recent discoveries about the heliopause have left scientists amazed and curious. They were taken aback by the surprising findings from the Interstellar Boundary Explorer in 2014. This spacecraft noticed a brightening of energetic neutral atoms, indicating that the heliopause had unexpected asymmetries that didn't match previous predictions. What's even more intriguing is the rapid changes detected by Voyager 1 and Voyager 2 in the heliopause. This unexpected evolution, known as entry-stellar, has sparked a renewed interest among researchers to delve deeper into the celestial boundary. However, the real shocker came last year when Voyager 1's Attitude Articulation and Control System, AACS, started sending garbled data instead of its usual operational updates. It was as if the spacecraft had developed a communication problem similar to electronic aphasia in humans, hindering its ability to convey coherent information. This anomaly has left engineers scratching their heads, wondering if the data received is merely chaotic or if it holds hidden patterns. Despite these challenges, scientists are eagerly anticipating the launch of NASA's Interstellar Mapping and Acceleration Probe, IMAP, in 2025. This new mission aims to unravel more mysteries surrounding the heliopause and the distant reaches of our solar system. In 2019, a concerning event shook the spacecraft that had been navigating interstellar space for the past 10 years. Despite regular status updates from the onboard system, the spacecraft's radio signal remained strong, indicating its overall health. However, NASA engineers encountered an unexpected issue with the Attitude Articulation and Control System. Instead of transmitting routine health and status data, the system started sending confusing and chaotic information. It turned out that a malfunctioning computer was corrupting all outgoing data, leading to this puzzling situation. Although the system has been fixed, The root cause of the malfunction remains a mystery, creating an intriguing puzzle for the team. Imagine the unsettling scenario of being alone in the vast darkness of space while your own systems start malfunctioning in inexplicable ways. This uncertainty raises questions about what else could go wrong beyond the protective reach of the sun's magnetic field. Despite these challenges, NASA's engineers had designed the spacecraft with a keen eye on potential encounters with extraterrestrial life. They were confident in Voyager's ability to navigate these unknown realms of interstellar space, keeping the possibility of alien encounters at the forefront of their design considerations. As Voyager 1 and Voyager 2 ventured beyond the protective boundaries of our heliosphere, they carried a captivating message from Earth in the form of the Golden Record. This record wasn't just any ordinary artifact. It was a deliberate invitation to any intelligent beings that might come across it during their cosmic journey. The Golden Record serves as a time capsule, capturing the essence of humanity. It includes a mesmerizing collection of sounds and images that reflect the diversity of human civilization and our interconnectedness with the universe. From the timeless music of Beethoven to the serene melodies of Guan Pinghu's flowing streams, from heartfelt greetings in 55 languages to the captivating sounds of Earth, such as thunder, bird song, and laughter, it encompasses a rich fabric of our existence. Even more fascinating is that the Golden Record provides visual instructions on how to play it, ensuring that even curious extraterrestrial beings can access its contents should they encounter it. As Voyager embarked on its journey, the prospect of an encounter with an alien civilization became tantalizingly real. While the likelihood of such an encounter in the vastness of interstellar space is slim, it's not impossible. Space's immense scale means that even at the speed of light, it would take considerable time for a signal to reach Voyager from Earth. This raises the intriguing possibility that an alien civilization might intercept Voyager and respond before we even receive their message. The James Webb Telescope, our window into deep space, has made a discovery that echoes through the field of astrophysics, a finding with big implications for the future of the Andromeda Galaxy. This galaxy, once seen as proof of our place in the universe, the Milky Way, the Andromeda Galaxy, our closest neighbor, is just one among approximately 100 billion galaxies in the visible universe. The sheer number of stars out there is mind-boggling. Previously, we believed the Milky Way to be the universe's focal point, a special hub. However, Galileo's revelations rocked the scientific community by revealing that it's merely a vast collection of stars scattered across space. Then, in 1750, English astronomer Thomas Wright added another layer to this cosmic saga. He proposed that the Milky Way isn't a chaotic jumble of stars, but a flat layer, with a portion of it housing our own solar system. It's incredible to think how limited our understanding was due to technological constraints. For a long time, we thought the Milky Way encompassed everything, but as technology surged forward, especially by the early 1900s, the universe unfolded its secrets, leaving us humbled and amazed. One of the most shocking revelations came from the Hubble Space Telescope, which showed us the grandeur of the Andromeda Galaxy, a cosmic giant akin to our own Milky Way. In the vibrant era of the 1920s, Edwin Hubble, an esteemed American astronomer, ventured into the cosmos using the Hooker telescope, a colossal instrument for celestial observation. Amidst the vast expanse of the night sky, Hubble's keen eyes discerned hazy, distant formations that led to an astounding revelation. These were not mere extensions of our own Milky Way galaxy. They were distinct galaxies in their own right, each hosting billions of stars in their cosmic embrace. Among Hubble's remarkable findings stood the Andromeda Galaxy, also known as M31. However, Andromeda was no newcomer to humanity's stargazing pursuits. Centuries earlier, during the 10th century, the perceptive Persian astronomer Abdul Rahman al-Sufi had observed this celestial marvel with unaided eyes, likening it to a diminutive cloud. Such was the grandeur of Andromeda that it remained visible from Earth without the aid of sophisticated instruments. A clear night sky and a bit of astronomical knowledge were all that was needed to marvel at its splendor. Fast forward to the 1600s, and the Italian observer Simone Marius delved deeper into Andromeda's secrets using a telescope, unraveling fascinating details about this enigmatic galaxy. It wasn't until 1764 that Charles Messier, a prominent figure in the realm of astronomy, bestowed upon it the designation M31. The twist in this cosmic tale adds a layer of intrigue. Despite Messier's attribution, the galaxy had already been noted by Al-Sufi centuries earlier. In 1864, the brilliant English scientist William Huggins conducted a close examination of the light emitted by Andromeda, leading to a groundbreaking revelation. He discovered that Andromeda's light differed significantly from that of other celestial bodies, marking a pivotal moment when the world began to comprehend the true uniqueness of this cosmic entity. Andromeda's sheer size is nothing short of astounding. To put it into perspective, consider the mass of our own Sun. Now envision a mass that ranges between 1 and 2 trillion times greater than that of the Sun. That immense scale is what defines Andromeda, a colossal celestial body that commands admiration and respect. Not only is Andromeda massive, but it also holds ancient origins dating back approximately 10 billion years. This extensive timeline encapsulates a wealth of cosmic history, making Andromeda a repository of ancient cosmic events and phenomena. One fascinating theory proposed by researchers delves into the formation of Andromeda. What if this colossal galaxy emerged from the merger of several smaller galaxies, a cosmic collaboration spanning billions of years? It's akin to a grand cosmic team-up, where gravitational forces gradually drew these smaller entities together, culminating in the birth of the majestic Andromeda we recognize today. This process of galactic mergers, while inspiring, isn't uncommon in our expansive universe. Picture two immense galaxies engaging in a slow gravitational dance, akin to giant cosmic whirlpools irresistibly drawn toward each other. However, this dance unfolds over such vast timescales that we are unable to witness it in real time. By the time significant changes become noticeable, a substantial portion of the merger has already transpired. For a considerable period, Andromeda was regarded as the elder sibling, towering over our Milky Way galaxy in size and stature. When you gaze up from Earth at the Andromeda galaxy, its vastness and splendor can easily lead you to think that our own Milky Way pales in comparison. However, recent discoveries have shaken up this belief. Scientists now suggest that the Milky Way might be just as massive as Andromeda, turning our previous assumptions on their head. Think about standing on a planet within Andromeda and looking back towards Earth. Suddenly, our galaxy doesn't seem so diminutive anymore. It holds its ground in grandeur. It's akin to finding out that your younger sibling isn't as little as you once thought. Yet in terms of sheer physical dimensions, Andromeda does have the upper hand. Its diameter spans approximately 220,000 light-years, eclipsing the Milky Way's range of 100,000 to 175,000 light-years. Picture it as if galaxies were urban landscapes. Andromeda sprawls across a vast territory, while the Milky Way is more densely packed with stars. These revelations shed light on the complexities of measuring galaxies. They are colossal entities, brimming with stars, gases, dust, and enigmatic dark matter. Determining their mass accurately is akin to attempting to count every grain of sand on a beach, with added layers of complexity. Such precision in measurement was unimaginable in earlier centuries. It took the advent of modern-day tools to unveil these astounding truths. For instance, the Andromeda galaxy houses an active galactic nucleus, akin to a beating heart emitting intense light across various wavelengths, from radio waves to X-rays. The presence of a supermassive black hole, weighing millions of times more than our Sun, adds to the spectacle. Most galaxies, including the Milky Way, host such gargantuan black holes at their cores. These aren't mere cosmic vacuums. They significantly influence the structure and evolution of galaxies. What's even more captivating is how stars and gases interact with these black holes. Instead of being swallowed whole, they form accretion disks, akin to neon signs in space, shining brightly and announcing their presence to the universe. These disks, along with stars orbiting these black holes in complex trajectories, create breathtaking phenomena observed in galaxies like Andromeda. During their closest approach to the black hole, stars experience intense gravitational forces akin to the universe's most powerful magnet pulling them in. This interaction leads to the release of energy and bursts, illuminating the galaxy in a dazzling display. When we peer into the heart of Andromeda and witness the twin lights dancing, we're actually observing a spectacular performance that has been unfolding for billions of years. This cosmic ballet unveils the intricate relationship between stars and the monstrous black hole at the center of the galaxy, offering insights into the cosmic dynamics at play in our vast universe. But wait, there's more to Andromeda's allure. Beyond its mesmerizing beauty, this galaxy harbors a hidden treasure trove of globular clusters. These clusters can be envisioned as tightly knit stellar communities, acting as satellites encircling the galactic core in a mesmerizing dance. Just imagine around 460 of these star-studded clusters, each brimming with hundreds of thousands to millions of stars, all born during the same cosmic era. The sheer abundance of these clusters unveils incredible tales about Andromeda's cosmic history. It hints at a galactic narrative akin to a mix bully over eons. Andromeda has engaged in what astronomers term galactic cannibalism, a process where its immense gravitational pull strips stars from smaller neighboring galaxies that venture too close. These stars, enticed by Andromeda's gravitational embrace, join its already vast and diverse stellar community, enriching the galaxy's cosmic fabric. Visualize Andromeda as a celestial collector, continuously amassing stars and clusters, expanding its cosmic portfolio. This characteristic isn't unique to Andromeda alone. Spiral galaxies, with their iconic swirling arms and flat disk-like structures, serve as ideal arenas for these dramatic cosmic encounters, painting a vivid picture of the dynamic and ever-evolving nature of our cosmic landscape. Some experts are now proposing a fascinating idea about the Andromeda galaxy. It's undergoing an extraordinary transformation, morphing from a typical spiral galaxy into a rare and enigmatic ring galaxy. These ring galaxies are like the unicorns of the universe, adorned with bright, youthful blue stars arranged in a distinctive ring pattern, while their centers remain shrouded in darkness, adding an air of mystery and allure. These cosmic celebrities stand out amidst the ordinary galactic crowd, showcasing three primary types of rings: nuclear, inner, and outer, each with its own unique characteristics. Nuclear rings snugly encircle the galaxy's core, while inner and outer rings extend further out, delving deeper. Ring galaxies come in two flavors, O-type and P-type. O-type galaxies feature a central nucleus with smooth, symmetrical rings, while P-type galaxies are more erratic, with off-center nuclei and asymmetrical rings. What's truly remarkable is that only a minuscule fraction of galaxies, roughly 1 in 10,000, earn the prestigious title of a ring galaxy. But how do these celestial marvels come into existence? There are two primary theories that astronomers propose. One involves a cosmic collision, where two galaxies collide, and the aftermath gives rise to a ring galaxy, as seen in examples like the Cartwheel Galaxy, an ARP-147. Another scenario involves a smaller galaxy zooming through a larger one, creating the captivating ringed beauty we observe. However, What makes this cosmic narrative even more